Section 9.1 Correlation. To begin, this chapter is pretty much, in a general sense, trying to create a sort of trend to pieces of information. A way to create a trend is by creating a line. So let's start off with a quick algebra review. So to begin, recall when you work with graphing lines. I'm sure you spent lots of time covering the different methods of graphing. A collection of points x, y can be used to create a line. One of the important equations was the slope-intercept form, which was y equals mx plus b. This equation is made to easily state the slope and the y-intercept. So this m would be your slope, and this point is your y-intercept. Now, what makes these points special? In other words, your slope is your steepness. So how far down, or like the steepness down or the steepness up you go. Your y-intercept is a point along this special vertical line called the y-axis. So this is a point that falls directly on the y-axis. It can be anywhere on that line. So let's begin with just a review question. The rainfall in Fontana, California in 2010 was 23 inches. During the last 8 years, rainfall has decreased by half an inch each year. Assuming the trend continues with the linear function model of the rainfall R of t for t years after for t being years after 2010. Okay, so if we wish to create a line, we said that our equation is called R of t, and it gets R for rainfall, t for time. We want to be able to state our slope, that'll have an x next to it, plus our y-intercept, our b. So these are the blocks of our formula that we need to find. Now, our slope is our steepness, and we see that it's going to decrease by half an inch each year. So because it's decreasing, it's going to be a minus 1/2. That's our slope. Our b is just our y-intercept, which is some initial starting point. And we said that we're going to start that from a 23-inch standpoint, and from there we're going to deduct half an inch. So with that, we have our solution. A constant rate would work as a slope. In this case, it is negative 1/2. For this problem, we are given a starting point of 23 inches, so our equation would be subtracting half an inch to the initial value of 23. Thus, our equation would be R of t is 23 minus 1/2 x. Actually, it should be R of t equals negative 1/2 x plus 23. But this is how we write it in statistics. We just change the order. Why? There's not really I'm not sure why, but I know this is how we like to write it in statistics. Our y-intercept followed by our slope. So this new application, we can be given information as two variables, and we can graph our findings as a coordinate point x, y, and we can graph them as a scatter plot. Remember a scatter plot? A scatter plot, in a general sense, is just we have 2 points, and we're seeing just some relation between them. So they're just little dots. We are left to determine the relation to these points, similar to a slope. This is what this section is all about, all while working through a statistical perspective. So here's our new content. Let's begin with the definition of correlation. A correlation is a relationship between two variables. Relationship between two variables. The data can be presented by the order pairs x, y, where x is the independent or explanatory variable and y is the dependent or responsible variable. So this is the way you can see scatter plots. So remember, they're just a collection of dots given two pairs of information, something like with weight or height, or levels, height of a building with how many stories, the weight of your cat and your height. I don't know, it can vary. It's just information, right? So with our scatter plot, we can have what is called a negative correlation, very similar to a negative slope. We can also have a positive linear correlation, very similar to a positive slope. It can be no correlation, which means we don't see a trend either going up or down. And it can be nonlinear, meaning it creates a shape that's not a line. In a given set of data, we can calculate type of correlations by using the correlation coefficient. Definition of the correlation coefficient. The correlation coefficient is a measure of strength and the director of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. The formula for R is, and don't use it. To calculate R, use StatCrunch. StatCrunch, I believe, is the best way to go about it. You can use a calculator as well. It's kind of a lot of steps to use a calculator. StatCrunch is more direct, so if I can suggest you to use StatCrunch, that's the way to go. You don't want to do this by hand. It's a lot of effort. Where n is the number of pairs of your data, so you do have to count off your pairs, and the population correlation coefficient is represented by rho. Here's an image of different correlations. Notice how the positive slopes go up from left to right, and the negative slopes go down from left to right. Remember, we read information from left to right, just like how we read books and we read sentences in English. So this is just a bunch of different scatter plots. Now, R is kind of like your steepness, but in statistics, the ideal R is R equaling 1, and it's the perfect positive correlation, and everything stems from there. We also have a perfect negative correlation at R equals -1. Now from there we can see different examples. Now this number R can vary, but let's give an example of a strong positive correlation. So we see that it's going up from left to right, and because we can see that a line would kind of fit there, our calculation, so this calculation above, that we'll use StatCrunch for, will give us this number, 0.81. And this will be a strong positive correlation. If we have, in this next example, we see there's not a definite line being built. And once we do a calculation, we see you get an R of 0.45. That's an example of a weak positive correlation. The same thing for this other example below. We have negative 0.92 as our R after our calculation, and because we can see a line forming going downwards, this would be a strong negative correlation. Or we can have a very low number that's not that close to 1, which is no correlation. Now here are your steps for using a calculator, but I highly recommend you to use StatCrunch. And we'll have another video where you're shown how to use StatCrunch with the homework example. So here's an example. A researcher conducts a study to determine whether the linear relationship between a person's height inches and pulse rate beats per minute. The data is shown on the table below. Calculate the correlation coefficient to interpret the result. So it's asking to find the R. So you're gonna, after this video, you can go ahead and try this example and make sure you get this as your answer by using StatCrunch or your calculator. That's it for 9.1. Thank you.